Hey guys, this is lesson 6.5 called Problem Solving, Finding Equivalent Fractions. Our essential question is, how can you use the strategy make a table to solve problems using equivalent fractions? Alright, so Anaya is planting a flower garden. The garden will have no more than 12 equal sections. 3/4 of the garden will have daisies. What other fractions could represent the part of the garden that will have daisies? So we're going to start off where it says, what do I need to find? Blank, that could represent the part of the garden that will have daisies. So that's this little last part that we're asking. We're trying to find a fraction, okay, fractions that could represent the part of the garden that will have daisies. What information do I need to use? We know that there are 3/4 of the garden will have daisies, and then we know that the garden will not have more than 12 equal sections. Okay. So how will I use the information? I can make a table, and that's what they're going to show us how to do down here. Make a table to find equivalent fractions. Okay, equivalent fractions to solve the problem. Okay, and if you're not sure what that says equivalent. If you need spelling, use that up there. Okay, so we're going to use a table, so I can make a table and draw models to find equivalent fractions. So if you want, you can get some colored pencils to help do the lesson, but other than that, I'm just going to kind of draw the best that I can in here. Okay, so they have this broken up into 4 sections, 4 pieces, because that's what my denominator tells me to do. Then my numerator tells me how much needs to be filled in. So there's 1/4, 2/4, and 3/4. Okay. Then coming over here, okay, they want to find another way that you can split up 3/4. Okay, so if you will, if you get your tiles out, go back here, if you get your tiles out and look at 3/4, 1, 2, 3, is there another fraction another fraction tiles that you can put on top of 3/4? Well, if you look really closely, does anything line up with this line right here? Okay, go down. Yes. Okay, so how many 8s is that? That's 1, 2, 3, 4, 5, 6. Okay, so go down here. Okay, so 6/8 is also equivalent to 3/4. Okay, so we have the same rectangle here. Okay, but this time we're splitting it up into groups of 8. So I'm going to cut this in half. Okay, and then let's see. I'm going to draw my lines here, split it up this way. Okay, so now I have 8 boxes and I need to fill in 6 of them. 1, 2, 3, 4, 5, 6. Now I'm hoping you're seeing that this honestly looks just like your 3/4, only just broken up differently, but it's, it has the same type of coverage. Okay, then another fraction that is going to be equivalent to 3/4 and 6/8. So I'm going to bring you back to the tiles here, and I'm going to show you that if we also look, is there any other tiles that match up to I'm going to go back to this one, that match up perfectly with the 3/4? I'm going to go down. We know the 8s did 6/8 and also 9/12. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9/12. I'm going to write 9/12 here. Okay, I'm going to go back and draw. Okay, this time I'm going to go okay, now I'm breaking it up into even more smaller pieces, so now I have each one of these is 1/12. So if I fill in 9 of them, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, So if you have your fraction tiles, lay 3/4 on top of 6/8, lay 6/8 on top of 9/12. They should all be perfectly laid on top of each other because they are all equivalent fractions, even though they don't look the same. Okay, and notice as we got into bigger denominators, that means the more smaller pieces that we had. Okay, so what other fractions could represent the part of the garden that will have daisies? So we discovered that 6/8 and 9/12 because they are both equivalent to 3/4. Okay, because they are, sorry, my pen's goofy. Equivalent to 3/4. Okay? And they represent the same part of the garden as 3/4. Alright, we'll go on to the next page and another problem. Two friends are knitting scarves. Each scarf has 3 rectangles, and 2/3 of the rectangles have stripes. If the friends are making 10 scarves, how many rectangles do they need? How many rectangles will have stripes? Okay, so there's a lot of information. So the first part says, what do I need to find? Okay, we're going to look at the end of that and find the 2 questions that we have. So I need to find how many rectangles they need for 10 scarves, and how many rectangles will have stripes. Okay, I need to find how many rectangles they need for 10 scarves and how many rectangles will have stripes. Okay, what information do I need to use? Each scarf has 3 rectangles. 2/3 of the rectangles have stripes, and there are 10 scarves. How will I use the information? I will make a table to find the fraction of the rectangles, the rectangles with stripes for different number of scarves. Okay, so we're going to make a table to find the fraction of the rectangles with stripes for different number of scarves. Okay, excuse me. Alright, so we have scarves, number of rectangles with stripes, and then we need to have the total number of stripes. I'm going to take my pen here. Okay, so I'm going to mark out like all 10 scarves. So here's scarves. Okay, and then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because it says that there's 10 scarves. Okay, then I need to figure out the number of rectangles with stripes. So I'm going to go rectangles with stripes. And then, oops, I don't want to get underneath with, okay, I'm just going to shorten that for stripes, and then I need to have the total number of rectangles. Total number of rectangles. Okay, alright, so for one scarf, each scarf has 3 rectangles and 2/3 of the scarves have stripes. Okay, so for one I'm going to put 2/3, because we know that for now. Okay, then when I'm dealing with two scarves, then I'm going to move up to 4, 6. And how I did that, or thought about that, is each time I've added a hole to that scarf. So if I have 2/3, I went to this number and I took it times 2/2. And remember what I said in the lesson before, this really means one whole. So 2 times 2 is 4, and 3 times 2 is 6. Okay, then I'm getting to my next one, which is 6/9, because I took 4/6, or I took, I took 2/3, the beginning one, 2/3 times 3/3. So 2 times 3 is 6, and 3 times 3 is 9. Okay, and then I got my next one for 4, 8/12. Okay, and again I took 2/3 times, I'm at 4 here, so 4/4, and I got over 8/12. Okay, so then you would just keep doing that. So I'm just going to finish off the rest. So 10/15. And you can check these too. 12/18. 14/21. 16/24. 18/27. And then 20/30. Okay, so this is kind of what I needed here, because it said if the friend is making 10 scarves, here we are at the scarves, 10 scarves, how many rectangles do they need? Okay, so they're going to need 30 rectangles, and then 20 of them will have stripes, so 20 out of 30. Okay, so coming down here, does your answer make sense? Yes, for one scarf, 2 out of 3 means 2 rectangles have stripes, out of a total of 3 rectangles. And then, so in the end, for 10 scarves, so for 10 scarves, 2/3 times, and like I did 10/10 at the very end, is 20 out of 30, which means 20 rectangles have stripes out of a total of 30 rectangles. Okay, so just kind of going back and reviewing what I did. So I put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scarves just so I can kind of keep track. And I knew that there was 2 questions that I needed to solve. How many rectangles do they need? And then how many rectangles will have stripes? So I put rectangles with stripes on top, and then I just put the total number of rectangles on the bottom. And each time I took 2/3 times 2/2. Then I got, that's what, how many, when there was 2 scarves, there was 4 with stripes, and then out of 6 total of rectangles. Then I went to the next one, and I went 2/3 times 3/3, and then I got that, and I just worked my way all the way to 10. So then I figured out in the end that there was 20 scarves that had stripes out of the total number of 30 rectangles. Okay, let's see, we'll do this page here. Keisha is helping plan a race route for a 10-kilometer charity run. The committee wants to set up the following things along the course: viewing areas, and that's at the end of each half of the course. Water stations, that's at the end of each fifth of the course. And then distance markers at the end of each tenth of the course. So which locations have more than one thing located there? So we're going to be kind of looking for a pattern here. First, make a table to organize the information. So they have the viewing areas, the water stations, and the distance markers. Okay, and then they have number of locations filled out. The first location was at the half mark. Then the water one was at the end of the fifth of the course, and then the distance was at the end of each tenth of the course. Okay. Next, identify a relationship. Use common denominators and find equivalent fractions. Okay, so they got the number of locations because they put the denominator here, 2, 5, and 10. So then we got to go and we have to find a common denominator and find equivalent fractions. Okay, so we have 1/2 here, and then, so 1/2, and then if you were to, so if I have right here, I have 1/2, so one part is filled in, and then I do another half, and the other part is filled in, so then I would have a whole. That's also written as 2 out of 2. We got to remember that when you have two pieces full out of two spots, then it's a whole. It's one whole because both pieces are filled in. I'm trying to make my thing smaller. Okay, that's smaller. Okay, so then we'll go, so that's 2 locations, so I have 2. Okay, then we have 5 locations, so we have 1/5, and then we'll go up 2/5, then 3/5, then we have 4/5, and then we have the last one, 5/5. That's one whole. Okay, same thing with 1/10. We'll just keep going up. So we have to do 10 of these. 2/10, 3/10, 4 out of 10, 5 out of 10, 6 out of 10, 7 out of 10, 8 out of 10, 9 out of 10, and then 10 out of 10. Okay, so then it says, identify the locations at which more than one thing will be set up. Circle those locations. Okay, so I'm going to change that to red. So we'll be at the 1/2, the 1, and then 2/2, 1/5, then all of these, 1/5, 4/5, 5/5, and 2/10, 4/10, 5/10, 6/10, 8/10, and then 10 out of 10. So I just went and circled at which more than one thing will be set up. Okay, circle the location. So both viewings, let me get my typer out here. Both the viewing areas, all the water stations, the distance markers located at 2/10, 4 out of 10, 5 out of 10, 6 out of 10, 8 out of 10, and 10 out of 10. Okay? Alright, and that's all the one that I'm going to answer. Actually, I could probably do number 2. What if the distant markers will also be placed at every fourth of the course? Will any of those markers be set up at the same location as another distance marker, a water station, or a viewing area? Explain. Yes. The marker located at 2/5 will be located at a viewing area and another distance marker. And then the marker located at 4, will be located at the last viewing area water station and distance marker. Okay. Alright, so I'm going to bring you to your assignment here. And I'm going to go with, do number 1 with you, and then I'm going to have to try number 2 and 3 by yourself. It's very wordy, but once you kind of figure out the pattern, then it's not so bad. Alright, so Miranda's braiding her hair, then she will attach the beads to the braid. She wants 1/3 of the beads to be red. If the greatest number of beads that will fit on the braid is 12, what other fractions could represent the part of these that are red? Okay, so I'm going to put 1/3. Okay, so 1 filled out of 3. Okay, she wants 1/3 of the beads to be red. If the greatest number of beads that could fit on the braid is 12, what other fractions could represent that part? Okay, so I'm going to take 1/3 times 2 over 2, because what I do to the top, I have to do my bottom. Okay, so then I get 2 out of 6. So I do this another time. Okay, so there's total of 6, and then I filled in 2. That would still work because it's not over 12. Okay, then I could go 1/3 times 3 over 3, and I get 3 over 9. Okay, and then that's how they got this one. And then I also could go 1/3 times 4 out of 4 and get 4/12. Okay, so hopefully that gets you started on that page. Make sure you look at Schoology and see what your assignment is. If you have any questions, please let me know. Otherwise, check or watch some of those parts in the video again. Alright, thanks. Have a good rest of your day.